Hello and welcome to a new coding video. Today we're gonna see if we can improve the Android app, and we'll also talk about general computing and technology and hardware and all that. It's been a while since I uploaded a video, so I'm sorry for that, but here we are. Okay, so first I want to tell you that the Optimal Launcher has been improved in performance-wise, even though it was already fast, but now it's faster. Okay, so right now the current version is the latest release is 1.84, 1.84. You can get it on the Google Play Store, and we will look at this and see if it has some crashes or similar. Actually, it doesn't have crashes, but let's see for the last 30 days, because it doesn't have 30 days, I think. And as you can see right here, we're kind of okay. We have 98.86% crash-free users. I'm sorry if you can hear the rain. So we're having unexpected climate change right now. But well, so the rain is turning a lot louder. I don't know if I should be continuing recording, but I'll just do it. Okay, so here we have a couple of issues, a couple of problems. But of course, some of them are from previous versions. And that is that we cannot do anything about it because those were already solved, I guess. Because there's no one like 184, right? So we will close them, I guess. I don't know, but yeah, I guess some people don't update the app very often, right? So that's something to take in account if you're a developer as well. That sometimes people don't update it. I don't know why, but yeah, the app is not very big. It's like 2 megabytes, and even a bit less for updates, I guess. But I will not be looking at crashes. I will be looking at ANRs as well. So here we have one that is affecting 184. So I would like to filter these guys by version 184. As you can see right here, it has 8 events, and these are the problems that we maybe should be solving. The first one is the only one that affects more than one user. The rest of them only affect one user. Okay, so let's see this guy. None of them are crashes, all of them are ANRs. So it's nice to have a release without crashes. Okay. Okay, so let's see. Here we can see where the crashes occurred and in which devices. For example, we have a Nokia C22 with Android 13, a Nokia C2 with Android 11, Vivo, Nokia. Almost 3 of 4 are Nokias. Okay. I really don't know. These ANRs are harder to debug than crashes, because crashes tell you, well, it crashed on this line and this file and that's it. But then ANRs, different story, right? So right here we have some things. We'll ask ChatGPT to help me with this ANR. So please help me with this ANR that is occurring on my Android app. It seems like your Android application is experiencing an ANR application or responding issue. ANR occurs when the main UI thread of your app is blocked for too long, usually due to long-running operations or blocking calls on the main thread. The stack trace you provided shows that the ANR is happening in native code libc.so, libutils.so, which indicates the issue may be related to a native library or component. Okay. Well, here are some steps you can take to diagnose and fix the ANR issue. Analyze the code, review the code, especially sections that may be performing long-running operations on the main thread. Look at the network calls, database operations, or heavy computations that are not offloaded to background tasks. Use that syntax or threads, optimize native code, profile performance, check for deadlocks, handle UI responsiveness, test on the different devices. What can I do in order to know what is exactly causing this? Maybe adding some sort of log or library that tells me where the problem is, or show more context about it. Okay. To pinpoint the exact cause of the ANR and gather more information about what's happening in your app at the time of the ANR, you can use several debugging techniques and tools. Logging. Add logging statements throughout your code to track the flow of execution and identify where the app might be getting stuck. You can use log.d, okay. Crash reporting tools. Integration crash reporting tools, okay. I know I have Crashlytics. These tools can provide detailed crash reports, including stack trace and device information. Okay, ANR traces. Enable ANR traces on your device to capture more detailed information than they occur. You can use the show and then develop options. Third-party libraries. Consider using a third-party library as Steto or Leak Canary to debug ANRs and memory leaks. Remote debugging. Okay, no, I mean something else. Something probably here in Crashlytics. We don't have logs. As you can see right here, it tells us that we can have logs here in Crashlytics. So probably we will see how to add logs. Customize your Crashlytics Firebase Crashlytics crash report. Okay, I'm on Android. I don't know why Android is not the default. iOS is kind of odd. In the Crashlytics dashboard, you can click into an issue and get a detailed event report. You can customize those reports to help you better understand what's happening in your app and the circumstances around events reported to Crashlytics. Instrument your app to log custom keys, custom log messages, and user identifiers. Report exceptions to Crashlytics. Automatically get breadcrumb logs if your app uses Firebase ATK. These logs give you visibility into user actions that led up to Crashlytics collected event in your app. Turn off automatic crash reporting and enable opt-in for reporting for your users. Okay. Add custom keys. Custom keys help you get specific state of your app led into crash. You can associate arbitrary key value pairs with your crash reports, then use the custom keys to search and filter crash reports in the Firebase console. When you're reviewing a specific issue in the console, you can view the associated custom keys for each event and even filter the events by custom keys. Note, Crashlytics support maximum 64 key value pairs. After you reach the threshold, additional values are not saved. Each key value pair can be up to 1 kilobyte in size. Use the set custom key instance method and text key value pair. And here are some examples. You can also modify. Okay. It looks kind of hard and tedious to do this. Set user identifiers, NDK only, add metadata to NDK. Report non-fatal exceptions, get breadcrumb blocks, enable opt-in reporting. Not very useful. So here, the only native code that I use is the one related to the drawing path. Maybe that's the reason. Well, I don't know. But I don't even know what these ANR means. Probably it's not that bad as well. Maybe it just hanged for half a second or something. I don't know. So there's lots of things here that can be done. I really spent a long time making these apps, you know. And I guess now LLMs can do it a lot faster. Probably they're not quite there yet, but they are definitely getting better. So, for example, in this case, I don't really know where to begin. I mean, what can I do? I have here the stack trace, as you can see right here, and says Android message native poll once, native poll loop once, looper activity thread, reflect runtime init, main. Here we have more threads. Sleep. Thread sleep. So I'm sleeping. Oh. Probably this is from a sleeping thing. If anyone knows how to better fix or solve these kind of problems, let me know. Yes, signal catcher. Leave art. Leave art. I think the problem is that I'm sleeping somewhere. Right? Probably. Probably that's the problem. Yeah. Probably that's the problem. Or is something caused by Firebase? Well, I don't know. Firebase is actually useful, you know. I cannot open this one. I don't know why that is. Apparently it's opened. Okay. So what I can say is that here's a coroutine as well. What I can say is that this probably is being caused by some sleep or wait function that I'm calling. Probably. I would say so. I would say so. Yes. So first I should look for sleep, and then I should look for delay. Right? Can I copy all of that? No, I cannot. I want to paste all of this in ChatGPT, but okay. So first I will search for sleep. Sleep. And here we have something. And Oh, this is nothing important. Then we have something in the main, which again I don't think it's important because it's not code related to the app. So this is some work in progress that I was testing this code, but this is just not relevant at all. So sleep is not about sleep. Let's see delay. And here delay, we have a couple of them. Yeah, it has to be delay, I guess. So this is one of the first. Here in resume, it says while loading path. This is resuming what? The path, drawing path. Okay, sounds good. So if the path is enabled, false is not enabled. But this is launched in a coroutine, so it's not waiting on the main thread. So I guess that should not be a problem, right? Because this launch is a background thread, it's not main, as far as I can say. Oh, is it? Oh, probably it is. Lifecycle scope. I will ask that to ChatGPT. If I launch a coroutine in Android Kotlin using lifecycle scope, will that run on the background? Sorry, I'm getting a call. Wait a second. Okay, sorry for that. So I was asking if I launch a coroutine in an Android Kotlin using lifecycle scope, will that run in the background? Or UI thread? Or what? When you launch a coroutine in lifecycle scope, it will run on the background thread by default. The lifecycle scope is typically associated with okay. Background thread, lifecycle awareness. Okay. So apparently, what do you mean? Why? Why using dispatchers IO? Common choice performing IO operations. I don't know what you mean. What if I don't use it? It will run in the context of the current thread. In Android, you launch coroutines, it will run the main thread by default. Okay. Really? I don't know, but these are not IO bound operations. Probably, well, this is the problem then. This is the problem. It's delaying on the lifecycle scope. But I don't know, but you told me that lifecycle scope is background. You're correct to launch the coroutine, as I said. You are correct that when using lifecycle scope to launch a coroutine, it is associated with the life cycle of the component, such as activity or fragment, and typically will execute on the background thread. I misspoke my previous response regarding the default dispatcher used with lifecycle scope. When launching a coroutine with using lifecycle scope in Android, it implicitly uses dispatcher's main, which is in the main UI thread dispatcher. However, since lifecycle scope is typically used with internal components activity fragment, the actual execution of the routine will happen in the background thread by default. What? This is because lifecycle scope is lifecycle aware and handles coroutine cancellation appropriately when the associated component is destroyed, preventing potential memory leaks. Okay, so if you use lifecycle scope to launch the coroutine without specifying the dispatcher explicitly, it will run the main UI thread, but the actual execution will occur on the background thread associated with the lifecycle of the component. What? I don't know. This ensures the UI remains responsive while any running operation performed in the background. I don't understand. Without it will run on the main UI thread, but the actual execution will occur in the background thread. I don't understand when you say it runs on the main thread, and then you say that the actual execution is on the background thread. I don't get that at all. Apologize. Let me clarify. Dispatcher, when you run, it uses dispatcher's main. This means that the coroutine code itself, including any suspending function, will execute the main UI thread. This is because the UI main is typically intended for UI-related code. However, the operations within the coroutine, especially suspended functions or long-running tasks, are dispatched to the background thread automatically by lifecycle code. This is done to ensure. I don't know. Okay. I will assume this is the problem, and I will try to fix this. Okay. So first we have this delay, and here I want to know if I can make all of this can you make this use a background thread by default, so I can call, or I can start a new coroutine using ls without having to specify that it runs on the background. Certainly, you can achieve by creating a custom coroutine dispatcher that corresponds to background thread. So using the default dispatcher for this, here's how you can do it. Dispatcher's default background thread lifecycle scope. This is not what I mean. ls launch. But I need ls is of type life cycle, so I get the benefits of life cycle thing. And so you want to maintain the default background dispatcher. In that case, you need to create a custom. So internally, but override the default dispatcher. Here you can do this. Okay, sounds better. I don't know. I mean, I guess I have to do the first thing that it suggests me, which is running with a dispatcher inside, which is this. I guess. So here we have a delay. And it says that, but inside here I have to put that launch. I probably can do here. Okay, let me see how do I do in the other dispatchers. Launch dispatchers default. Launch dispatchers IO default IO. Okay, so that's the first fix, let's say, to this thing right here, because here this is delaying for a quarter of a second. Why is this delaying for that? Oh, this is not actual code that is being used by, but okay, anyways, this is not code that's being actually used right now. But okay, so here we have delay 1 second. So we were calling on resume from somewhere. It's from here apparently. And here we have launch dispatchers default. So that shouldn't be a problem. Here, however, we have something different. Then we have to also do, sorry, another call. Okay, sorry. So we're back. Actually, it was those guys that wanted to tell you something. I didn't even answer the phone. Okay, so going back to this, I mean, I think the only explanation for this that I can find right now is that I probably should use IO. Is that this is not being used the right thing. So probably I have catched the source of this ANR. Probably. So I just have to do that and that will fix it. As simple as that. So let's see if this one, is this done? No, it's apparently not done. So we will do a dispatchers.io. Okay. Will that be enough? Well, I hope. I hope. Dispatchers.io. Okay, now I will continue doing this. I am looking for a delay with a call. So here we have this. This is launch. This is another thing that should be dispatchers.io. .io. I'll do everything IO. This is IO. Okay. This guy is not IO. So this now is IO. Sorry. This is okay. First, this is IO, IO, IO. This is not IO. Okay. This is not IO. Why? This has to be called from a coroutine, right? Okay. On resume, dispatchers default it says. Well, I will do IO rather. Is that okay? I guess. But I don't know. Okay. I guess. I don't know if it will work, but okay. So IO, IO. This one is the one that I fixed. So this one's IO. This one, IO. This one is not IO, so I mean, there's lots of things that you have to learn, right? To use the tools in the right way and not misuse them and all of that. It's kind of a not very cool, not very straightforward. IO, IO. Here we have another this not IO. So dispatchers.io. Here we have another one. dispatchers.io. So I guess this is the reason that I am getting those errors. Okay. I guess. Okay. Okay, let's see. Is this IO? Yes. Yes. What was the difference? Oh, it's another thing. Okay. Yes. Yes. Oh, this is not. Okay, this is also not yet fixed. Dispatchers.io. Well, at least if this is the fix, it was not that hard, right? Bit tedious, but yeah. I should have done a replacement thing, right? To be able to do this faster. Okay. Just to double check. Now I have to ensure that the app will work okay with this change that I made here. Will it work okay? Well, I hope. Okay, everything's done. Now I will run it to the emulator to see if it works well. And hopefully, if I did it correctly, then these actually all the ANRs, well, at least this ANR that is related with 4, the only one that is like kind of important, the one that is related with 4 users and 4 events will be fixed. And these OL probably as well will be fixed. So at least this one. Okay, let's see this one. Not working. Do I have internet? Am I connected to the internet? Yeah, so. Let's see if we can find something. So here we have a thing. U329. U329. Okay, so let's see. U329. Okay, but where it called from? It's called from main 203. Main 203. Okay, where's main 203? Oh, why is that? Well, I don't know. But okay. So, the app is running. Let me move this right here. The app's running. It's working. Yeah, I don't remember where it had this guys. Okay, so drawing path. So let's see drawing path. What can you do? Okay. Seems that it's working. Okay, but apparently, these things are hard to pinpoint actually, but Okay, let's see if I can go somewhere else where this may also be cold. This is not one of them. Days on resume. On resume it says. Not bad. So I think probably we have fixed it. Taller note. Okay. Taller notes. Okay. Let me add a note. Make it green. Make it taller. That works apparently. Well, I think it works. Shorter notes. Joint path. Reload. What's this? Dataset changed. Yes, I think this is the problem. This was the problem. Yes, I think so. It's not a very common one, but it occurs. I think this fixes the problem. Of course, I will not just send the app right now, even though I haven't changed that much of the code. Before sending the app, I will test it more. I will daily drive it a couple of days and a couple of devices, and only then, if nothing bad happens, then I will upload a new update. So I think that will be it for the Android section. I also want to talk in this video about hardware. And you know that AMD, Intel, what else? NVIDIA, Apple, Qualcomm, ARM, x86, whatever. There are different available computing devices today. Recently I heard that NVIDIA just launched or announced a new product, a new GPU for AI, I guess, because that's the hot thing of today, in which it will likely cost about $30,000 or something, and that's a lot of money, So that means that there will be single processors, such as that people will not be able to buy, right? Of course, right now because it is too expensive, and yeah, there is a demand for it. That's why they made it, and that's why they have more than $1 trillion valuation. But the thing is that we are now moving towards a time in which a single GPU will cost more than a car, even a brand new car. And that tells us how valuable GPUs are, and that tells us how valuable NVIDIA is, and that tells us how valuable AI is. So, it will create this big gap between the ones who can afford that and the ones who can't. But you can say, well, but it always used to be like this because you know, top 500 computers, top 500.org list, whatever, they they cost like tens of millions of dollars, even hundreds of millions of dollars to build. Yes, but they were like made by buying lots and lots and lots of this device and connecting them. For example, right now I could not buy that sort of GPU. I would like to, I would love to, but just can't. So what are the alternatives? Because right now but also I don't really have the need for it. I mean, maybe I want to, and I can do cool things with it, but I don't have a way of justifying that expense, right? Uh, I could say for investigation, that's the justification, but I don't know. I don't have a way of funding that. Whereas people that use this in a way that produces them money, then sorry for the background noise again. They can say, well, I'm using this to produce money, and I will produce more money than this thing costs. So it makes sense for me to buy this. That may be, Mark Zuckerberg with Facebook, Microsoft, OpenAI, all these guys, Tesla, whatever. So those guys, these kind of products are targeted toward these big companies with big market caps and big loans and big bank accounts. So what I'm trying to say here is that now there will be single computing devices that very few people will be able to afford them. Yeah, right. And I would like to explore a bit more in that because GPUs allow to do parallel stuff a lot faster. But I'm not yet ready for it. I mean, right now I don't have a workload that will benefit from GPUs that much. I am trying to learn about it, and I guess I will eventually get there. I hope in less than a year. But right now I simply don't have it, don't demand it right now. And because why I don't demand it? Because I think there's so much still that you can do with regular CPUs. There's lots of things, and once you have done that, whatever you're working on, you can then accelerate that using GPUs, if that works, that makes sense for you. But before doing that, you have to have the thing that you want to accelerate. I think, at least that's what I think, how I think. So in my case, I first will build the thing that I want to accelerate, and once it's built and works, then I will accelerate it using GPUs. But that day is still not today. That is why I'm still working with CPUs. And I also have a GPU like 1600 GTX whatever, NVIDIA, which actually is rendering these graphics. But these graphics can be rendered with an integrated GPU, right? So maybe I could use this one to learn CUDA, even then. And only when I adapt it to CUDA, whatever my project, only then I can start thinking about buying new GPUs, right? For my case. Maybe your case is different. Well, that's fine. But my case is lower, let's say, because I am trying to understand and learn it from the ground up. Not quite, but kind of. But yes, I have done some experiments like computing some things in the GPU, but I'm a very beginner on that. And I'm talking from the programmer point of view, because I know that I could download whatever open source project that uses GPU and just run it. I mean coding for the GPU, right? Actually. So yes. Having said that, then right now I'm still not ready to buy a GPU. I'm just don't need it. So what I need though are CPUs. And if you want to hear me talking a bit about which CPUs are today best in my opinion, or the ones I would buy, well, stay in the video. Otherwise, I mean, this is it. So, in terms of GP and CPUs, I was thinking, okay, there's Apple with ARM, with Apple Silicon. They improved a lot from Intel since a couple of years ago, since 2020, I think. So that's one option. So then we have AMD, then we have Intel, then we have Qualcomm. Okay, because Qualcomm also, and these chips are, I want to code and this and run code in these guys. So that's basically the uses for these CPUs for me. So I look at them, look at the prices, and look at the technology and all that. And the winner, or the CPUs that I would buy, the most interesting CPUs for 2024 that are at least announced, are two. One from AMD and one from Qualcomm. So Qualcomm is the Snapdragon X Elite, and AMD, but it also depends on the price of the X Elite, right? And AMD would be the the Ryzen 5 8640U, 8640U, or the Ryzen 7 8840U, and also the 7000 series if that's okay. But though the equivalent for those for the 700 series, if you don't find the 8000 series useful, okay, that's fine. Why not Apple? Why not Intel? Well, first, why not Intel? Because they use too much power. And I don't want my thing to use power and use the fan at all times. And also, I don't like things that are not efficient, right? So these guys, I don't know how. I think they use less than 20 watts or something. Yeah, they use like 15 watts, which is great. And why not Apple? So why not Intel? Because of the watts, how much energy they use, and they get a lot hotter and all that. That's it. And these are laptops, CPUs, but I would be buying, in case I buy them, I will buy like in a mini PC kind of thing. They're quite very very interesting mini PCs. Though that is the hardware that I would buy. That's the personal computer that I would buy, because I can leave it connected 24/7, running code, and write code and that, and I mean perfect, you know. So that's why not Intel, and now why not Apple? Well, first of all, because this generation of chips from AMD are very powerful. So Apple is not longer a lot more powerful than these guys. Then they use 4 nanometers, so pretty efficient. I think the most expensive chip of Apple uses 3, and the other uses 4, and the other uses 5. So these from AMD use 4 nanometers. So, and the other thing is that the Apple chips are designed for Mac OS. It's hard to install Linux on them. Okay, And the other thing is that Apple is just a lot more expensive and with limited RAM. So if I want to have 32 gigabytes of RAM or even 64 gigabytes with AMD, there's no problem at all. But if I want to do that with Apple, it's impossible. I think it's just impossible unless you choose the max variants, which are like $2,000 more, and that's not smart to do that, especially when next year there will be something better and you have to throw out the thing that you purchased this year. So paying $2,000 extra is not smart, to say the least. So I would say AMD is the winner. I just saw today that ASRock announced a thing called 4x4 or 4x4 box, I think it is. And this is the mini PC, like just as a Mac Mini. I have a Mac Mini right here, about the size of Mac Mini, with these chips. And this machine, I think, is not yet ready to buy, but it's like in pre-sale or something. It's almost ready to buy. So it will be possible to buy these sooner than the X Elite. So this costs around $500 to $600, and you can install lots of RAM on it. Now, in terms of performance compared to the X Elite, in single core is the same. AMD is also actually a bit more. But in multi-core, the X Elite is like 20% more. But yeah, I mean, it will all depend on the X Elite price and also compatibility with Linux. Because I don't think the X Elite, maybe the X Elite support for Linux will be okay, but maybe not as good as AMD. So AMD is the best, in my opinion, CPU maker in the world right now. Right? Better than Intel because it uses less power. Better than Apple because it is cheaper and supports Linux and more RAM than Apple. And better than Qualcomm because it will be available sooner. But Qualcomm may be better if they offer a good price. Right? If they offer a good price. So if there is a mini PC with the Qualcomm thing, with 32 gigabytes of RAM, and so under $700, which I don't know if that will be possible, but if there is, then these AMD chips will have a competitor. Otherwise, not. So I think, yeah, AMD, again, will repeat the chips. The chips that if I buy new hardware for this year would be either the Snapdragon X Elite or the AMD Ryzen 7 8840U or AMD Ryzen 5 8640U. So X Elite, 8840U or 8640U. Of course, the 8840U has more multi-core score than the 8640U, right? So that's it. So that's it for this video. Thank you for watching. I hope you liked it, and I see you on the next video. Bye.